All right. So hey, everybody. My name is Jen Villa, Director of Product here for Databases.
And I'm Edward, an engineer on the AML squad.
And we're going to be talking to you about how we're applying AI and ML in Grafana Cloud to save time, toil, and money. This is our QR code for Q&A, so please give it a snap. We'll have some time at the end, hopefully more time than at the keynote where we ran a bit over, but time at the end for questions. All right, so let's start by talking, just kind of high level framing the problem. I think of automation as about freeing up human potential, right? As about taking time that we used to spend on rote tasks and giving us time to instead spend on more creative, innovative work. The example I've laid out here in the images is if you think about information distribution, we started with monks in monasteries copying text by hand. And we came up with the printing press, allowing for mass distribution of printing materials. Fast forward another 100 years, we automated even further, and we invented the internet, right, which gave us global, instant distribution of information. I won't say that we fully automated away the need for written materials, because I still love a good book or my Sunday crossword, but you can still see kind of the progression that we have managed through automation. Now, when we think about AI/ML, I think of that as a tool, a technique for automating things that we never thought possible before, new problems that we can tackle with automation. And we see this happening in so many domains, right? In healthcare, we see it analyzing imagery to give us diagnoses. We see it helping us understand how proteins are going to fold. We see it in finance to detect fraudulent activity. We experience it daily as consumers, giving us better customer service interactions, better recommendations. And yes, I use it to help me write the many emails that I write as a product manager. Since unlike Edward, I do not do anything effective like writing code. I just write emails and Slacks. Now, when it comes to observability, we talked yesterday about how we think the main impact of AI/ML in our industry specifically is that it's going to allow you to scale the promise and the power of observability across your entire organization so that it's not just specifically localized to the couple of expert practitioners, the couple of veterans that you have. You make that power and that promise available to all engineers. And I think what's especially unique and specific about how that's going to happen is that it's going to help engineers identify and fix problems in complex distributed systems. And that change, I think, honestly, couldn't come fast enough because at the same time that we're seeing this trend, we've also seen over the past few years the trend where more and more companies are moving away from a monolith to a distributed system. And why has that been happening? That's been happening because we want to make software engineering teams more and more effective and efficient than ever. We want to empower them to ship changes to all of your customers faster so that those customers have a better experience. So we've taken these large monoliths, we've started breaking them apart into many different decoupled services, and that allows each team to move much more quickly. But there's a trade-off there, right? As we've made that move to these more distributed systems, we've introduced more complexity. So look at this node graph, right, with all these different entities and connections between them. And what that means is that when something goes wrong, it can be a lot harder to figure out what's going on, right? A single request may ping through services owned by tens of teams, may ping between cloud and an on-prem data center. So there is a lot to figure out about, where is this problem coming from? And so that's where we think AI/ML is going to be a critical tool and technique in helping engineers take in that ever-increasing complexity and figure out what's going wrong. Now that I've blabbed at you about the theoretical impacts for a while, I'm going to pass it over to Edward, who's actually going to give you some examples of how we're applying AI/ML in Grafana Cloud to help you all root cause problems faster.
Thanks, Jen. So building off of the AML theme of saving toil, we've been building features throughout Grafana that will make your day-to-day easier. So many of our time spent within Grafana is on troubleshooting. And put simply, troubleshooting is complicated. Looking for that signal in a sea of telemetry data is a big challenge sometimes. So I'm here to share some new and existing AML features within Grafana that helps essentially help you identify and fix problems faster. So these features are available throughout the new Explore apps as well as Sift. They are both available free in Grafana Cloud, and some are available in open source as well. So the first challenge we have is that our logs are often noisy and verbose. It's not fun scrolling through pages and pages of the same thing, looking for that needle in a haystack. So here's an example of some logs I was looking at the other day. You can see maybe there's 3 or 4 distinct patterns, but it kind of sucks having to look at every pattern repeated all the time. So we're introducing log patterns to group similar logs together. So you only have to look at each pattern once instead of looking at the same thing repeated. So this also allows us to keep a trend over time, so we can pick out the logs with high value when we are actually looking for an issue. This feature is available in 1 or 2 places. First, in Explore Logs, we are highlighting the pattern so you can find what you're looking for easier. We surface logs that has log patterns within a given time range, so you can pick and choose for the logs you're actually looking for. The second place is inside Sift. So we surface log patterns with errors when you're not sure what to look for yet. And we highlight the logs that have had a large change in the last 24 hours, as these are potentially new error logs you want to be looking at. So the second challenge is that it's kind of hard to understand time series. To understand time series, we need to answer 2 questions. One, is this series behaving abnormally compared to other series? Or 2, what is a good threshold for abnormal values in a series? Simply by looking at the series themselves, it's hard to draw conclusions, and even when you spot a pattern, it's not always obvious whether or not that's important. So our dynamic alerting feature consists of forecasting an outlier, tries to pinpoint the anomalies in the series you give it. You can find these in the machine learning section under alerts and RM. So outlier detection helps answer the first question by highlighting the abnormal series in a group of similar series. Forecasting answers the second question by trying to predict a plausible range of each series, so that you can use these ranges to then apply dynamic thresholds for alerts. So these features have been out for a while, but we're still making constant improvements. One of the newest improvements we're trying to make is to help you create forecasts easier. So on screen, you see as soon as you make any changes to the model, the UI reflects that change. So third challenge we're going to talk about is looking for trace spans. So traces allows you to follow a request as it traverses your stack, and each span gives you, represents one operation in this request. It offers things like duration, errors, and any metadata. Traces offer great insights into your application, but the best kind of traces are often the ones that have tons of spans, and looking for that important spans in a deep trace is a big challenge sometimes. So to help you find that interesting span without digging, we've enabled our Sift feature to track spans of interest. For example, spans with errors or high latency spans. Sift will then highlight any spans with a big change in behavior. So this is done by comparing the volume of spans in the investigation period against the volume in the last 24 hours. So slow spans and error spans are still a work in progress, but should be available in the near future. The fourth challenge is understanding profiles. So profiles measure the resource usage, say CPU and memory, of an application over time. We visualize profiles using Flamegraphs, which are stacked bar graphs representing function calls and their resource usage. Flamegraphs are great to look at, but there's a lot of information to unpack. So we built a Flamegraph explainer inside of Explorer Profile to help you quickly get started with profiles. This explainer will highlight any issues, root causes, bottlenecks, and recommend fixes. So Flamegraph explainer first processes the profile, only keeping the important bits, feed that into an LLM, and ask it to digest it and provide recommendations. So Flamegraph explainer is available open source inside of Explorer Profiles. Now, extracting insights from raw telemetry data is valuable. We're even more excited about AI/ML capabilities that we can build on top of these insights. So let's start with alert. You get an alert, you suspect something is wrong. We currently have a ton of tools to help you figure out what's wrong, but as Jen mentioned earlier, your system gets complicated, there's so many signals, so many noises. Can we do better using ML? So here's a sneak peek of something we've been working on internally and testing. We call it service level explanation. So we get an alert saying that the machine learning prediction service is having issues. So our model immediately starts scanning all the observability signals. So by the time you start looking at the issue, we've already displayed something. So first, we're displaying a service dependency graph, and each component is highlighted with a value of 0 to 1, highlighting the probability of contributing to the current issue. So this model has highlighted Salary and Redis as two internal dependencies, as well as Auth API and GCOM as external upstream dependencies. So below the graph, we show potentially top metrics that contribute to the error. We can click on the metric to see the time series, or we can click on the service name to go to the logs. So let's quickly take a look at logs for the salary worker. So we noticed some errors in the past 20 minutes, and we look at the errors, and it shows that Redis, the worker has issue connecting with Redis. So let's try to verify this by looking at the logs for Redis. And we can see that Redis has shut down recently. And looking at the Redis metrics, we can see that the metric stopped emitting completely.
Oh, it died.
So essentially, the model was able to narrow down where the issue is without us having to dig. We're currently only showing the service graph and the top metrics, but we're hoping to incorporate other signals in the service as well. We're seeing promising results internally and hope to release it in Grafana Cloud in the near future. So now I'll pass to Jen to talk more about how we're using AI/ML to make observability more affordable than ever.
Thanks, Edward. All right, Edward got the cool stuff about how we're using AI/ML to improve root cause analysis. I get the more boring stuff about saving money, but I'm also kind of weird, and I think that the saving money part can also be pretty fun and exciting. And so what I'm going to talk to you about is a little more depth into what we went yesterday in the keynote, is about how we're applying AI/ML via our adaptive telemetry strategy to help everyone adopt observability at greater and greater scale, because we're making it more and more affordable than ever. And touching back on what we hit on yesterday, not only do we want to increase the cost effectiveness of observability, we want to empower all engineers at your organization to participate in that mission of improving your costs, right? We don't just want that to be in the hands of a select few. Adaptive metrics. So you would have seen these stats yesterday at the keynote, but just calling them out again, we've really been impressed with the amount of adoption that we've seen around this feature. If you translate that 640 million into series save, that's going to be tens of millions of dollars saved across our customer base every year. Now, what's really cool is that since the launch, we've continued to improve, in particular, our recommendation service. That is the service in which we are identifying metrics that are candidates for aggregation. And so when I say improve, I think it's really in two areas. So one is around the sophistication of the recommendations that we're able to make. Most recently, for example, we've introduced the use of ML to calculate confidence scores, which actually allows us to figure out if a particular query that was run at your organization, should we really consider that when we think about whether or not a metric can or can't be aggregated, right? Because sometimes you might query a metric just to kind of know what it is a little bit or see what it exists. And maybe it doesn't make sense then to say, hey, I can't aggregate this metric at all because of that one query. We're also making the recommendation job more and more real time. Now we can detect changes in your usage. Maybe someone adds a dashboard, someone adds a new alert within the hour, and we will immediately regenerate our recommendations from there. In fact, internally, we have developed so much confidence in the recommendations that we apply them ourselves, any new ones that come up, daily, with no human in the loop. That means that we're dynamically aggregating and disaggregating our metrics as a company. Now, we totally understand different customers may choose different approaches. They might want more manual control. But another thing that I think we've developed to really help human operators feel like they're still able to use their intuition to influence the recommendation service is our exemptions concept. So while the machine intelligence is suggesting, hey, here's what I think you should aggregate based on the patterns I'm seeing, we also have this concept of exemptions where you can say, hey, this particular metric or this particular label is very important to me as a company. I do not care what the usage patterns are, never aggregate it. And so we apply that concept internally, and that's another part of the reason that we have felt confident to apply these recommendations with no need for review anymore. Now, we've made this automation available to customers as a GitHub action. So we encourage those of you who are interested to take a look, scan the QR code, it'll take you to our repo, and see if you want to join us in the brave new future of auto-applying your recommendations. All right, I see some phones up. I'll give you another 5 seconds. All right, and now what I'm going to do is go into a little more depth on adaptive logs, which yesterday we mentioned is generally available, which means any of you can go into your Grafana Cloud account and start using it today. Now, let's start with the numbers, right? Our early access cohort of customers is already cutting log volumes. We're seeing anywhere from 10 to 60%. I think if you looked at my number in the keynote yesterday, we said expected 40 to 60. That's because we see most of the customers kind of gravitating towards that larger number. Internally, we're reducing our own log lines ingested by 40%. What you see here is actually a time series graph showing the rate at which we've been reducing our ingestion volumes. You can see when we started pretty conservatively, trimming the ingestion rate by about 10%. We got a little bolder. We got up to about 15. Then we had to turn it off because something broke. But that's software development. Some time went by, and then after we were like, hey, this seems to be working. No one else has really shouted at us too much. You can see we cranked it up to about 40, 45-ish%, which is where we are now. You can see, obviously, that number is not constant because the log volume that our applications are throwing off, right, is also going to vary in response to load on the system. Now, I talked about the results. Now, for those who are curious, we're going to pull back the covers a bit and go into how it works. This is a fake image that is not actually the machine running adaptive logs. All right, so let's start with the write path. So what's happening is that on the write path, we're analyzing all the incoming logs that you're sending to Grafana Cloud. And we're using the ML algorithm known as Drain to extract patterns. We're running what we're calling a pattern miner service, and that service's function is to do that extraction. Those patterns then get stored in object storage. What's really interesting is that Edward talked about how Drain is being used in both our Sift feature and in Explore logs. So it's the same algorithm, but we've actually changed the parameters slightly, like you tune Drain when you run it. Whereas with Explore logs, we've kind of focused on trying to get a smaller set of patterns, right? You're in an incident, you're trying to look at what's changing. With adaptive logs, we've actually tuned it to allow for a longer set of patterns, because there we want to identify more potential savings. And you can kind of analyze and apply those savings over time, right? It's not going to be a time-critical situation where you're trying to quickly scan. So that's what it looks like on the right path. And then what we land on is a set of patterns, and then a rough count of what is the volume represented by that pattern. Now, what happens on the read path, right? We want to understand both how much volume is coming in, but then what is the usage? How are you interacting with your log lines that are coming in? There, we're actually looking at the results returned in every single log query you run, whether that's a database running it, whether that's an alerting or recording rule running it, or whether it's just someone using Explore logs. We're looking at all of those queries, and then we're looking at the returned lines. And we're counting, say I'm returning 100 lines in your query, how many of those lines match the particular set of patterns that I have. And it's very important to note that what we're looking at is not scanned lines, but actually returned lines, right? If you think of a log query, you may scan terabytes and terabytes of possible lines, but you only end up returning the results that, say, have some certain string, right? So there, again, we're using this pattern miner service that's going to also update our patterns to say not only here is the number of ingested lines, but also here's how many times that pattern is returned in a query. And this becomes our basis for generating recommendations. With a kind of rough rationale, how they come about is if you see a pattern that is returned a lot in queries, we think that means it's probably valuable to you. If you see, on the other hand, a pattern that's generating a ton of volume, but it never ends up getting returned in any query you run, probably not that important. I'll speed through that. And now I'm going to take you through our UI for working with adaptive logs. So here's what it looks like. You're going to see adaptive logs under the cost management section of Grafana Cloud. Let's start with the patterns I talked about. So here's all of the extracted patterns. You can see we have 600 or so. The next thing you can see is the volume. So that's the volume associated with that pattern over the last 15 days. That's what we're analyzing right now. Then we're showing the query to ingest ratio of that pattern. So in this case, I ingested 3.4 terabytes of lines matching this pattern. And by the way, in terms of queries run over the last 15 days, I returned roughly 350x that volume in query results of lines that match this pattern. So in that particular case, we're not recommending doing any sort of dropping of log lines matching this pattern because we're seeing it returned in queries so frequently. Then I could sort of scroll down to, say, a pattern like this, where we have the opposite kind of relationship, where we've ingested about over a terabyte, but we haven't done, say, as much querying of it. Now, there's kind of two ways that you could possibly approach applying these recommendations. So one option is you could say, I want to do a quick, like, let's do a batch apply. I love this philosophy. I'm all bought in. YOLO, let's do it. There, at least, we have one thing that we think is a super helpful guardrail, which is that you can set a maximum drop rate. So let's say 25%. That lets you set a ceiling on how much dropping will do. So say that we're recommending, in this case, drop 79%. Well, by using the max drop rate, we're actually going to kind of have 25% as the ceiling. So if I set that, you'll see here it's 25% and not 79. So this allows you some, again, control as an operator, like what is it that I'm comfortable with. You know, maybe you don't like that, let's apply everything at once. You want to be a little bit more cautious. Then I think we offer a bunch of nice little features in the UI that makes it easier for you to review the recommendations one at a time. So for example, we'll actually break down for a particular pattern, where are we seeing that pattern coming from in terms of the specific service that is generating it, right? So it turns out 100% of the log lines with this pattern are coming from Loki, right? Same here, 100% are coming from Loki. You can actually then apply that filter at the top level. You can say, show me all patterns coming from the Pyroscope distributor. That's helpful if you say, no, hey, I really care about the Pyroscope distributor. Maybe I recently introduced some changes there, and I want to make sure I keep most of those logs. You can also filter by text in the pattern itself. So I only want to look for patterns that have the string request in it. That's helpful if you're an engineer and you're like, I think maybe I introduced like a chatty log line a couple of weeks back. Let me see if that's showing up in any of my patterns. So then it's kind of up to you. Let's say I want to apply a couple of recommendations here. I'm going to just type in some numbers somewhat randomly. You can quickly get a preview of your projected savings by making these changes. And you can then go ahead and click Apply. I would say the changes tend to take effect in about 5 or so minutes. I'm not going to make us wait here for 5 minutes while those changes take effect. So instead, I did this on Sunday as a trial run. And what you can see kind of roughly here over this 5-minute period is this was before I applied a bunch of these recommendations. You can see this is bytes received total. So that's an ingest rate. And you can see how they're a drop down my ingest rate from about 25 million bytes per second to roughly 18 million bytes per second. All right, can we go back to the slides? All right, I think that's pretty much all I have on my whirlwind tour. This is a QR code that would take you to our blog post where we talk a little more about adaptive logs. And we would love to get your feedback. Find Stephen Dungan, he's our PM, and Quinton from product marketing. They're here and can talk to you more about the feature in depth. And we're excited to continue to build out the adaptive telemetry suite. So we have 2 already in GA, and we're actively starting on development of adaptive traces. All right.